Hello learners, welcome to the next session on quantum machine learning. So in this session we are going to discuss about type of machine learning. Here we are going to focus about unsupervised learning. So in the unsupervised learning we are going to involve training on unlabeled data where the goal is to find hidden patterns, relationships or structures in the data. So main characteristics of unsupervised learning is no labeled outputs. So we are going to find out the patterns or grouping in that data. So we may have a different kind of application in unsupervised learning. The first one is clustering. The next one is dimensionality reduction. And the third is anomaly detection. In the case of clustering, we can easily group the similar data points, right? So this is very important application in product recommendation system. The next is dimensionality reduction. Here we are going to simplify the data. So we can have different kind of approaches are there. The first one is PCA. This is specially for feature extraction. And the next is anomaly detection, identifying the unusual data points. Especially we can apply this thing information into fraud detection. We can have a different kind of algorithms are there. K-means clustering, hierarchical clustering, principal component analysis. So these are the very simple introduction about unsupervised learning. In the case of unsupervised learning, we can have a different kind of algorithm is there. Clustering algorithm. So clustering algorithm is very useful to group the data into clusters based on the similarity or distance measure. Distance measure is very important metrics to identify the different kind of clusters so that only we can easily group the customers. For example, in the product recommendation system. These are the widely used in market segmentation, image analysis and social network analysis. Example, K-means clustering. In K-means clustering approach, partition the data into K clusters, minimize the distance between data points and assign the cluster centers. The next is hierarchy clustering. Based on the structure or it may be hierarchy of the cluster, we can go two different kind of approach. The first one is augmentative clustering and diversive approaches. The next is DB-scan approach. In that density-based spatial clustering application, we can go with that so that we can easily identify the cluster of high density, so based on the noise areas. And the next thing is Gaussian mixture models represents clusters using probabilistic distribution and assign the probabilities to data points belonging to each cluster. The next thing is dimensionality reduction algorithm. This algorithm is very important to reduce the number of features in the data set. So in order to keep the information as a preserved manner. Commonly used in visualization, data compression and noise reduction. The example is principal component analysis projects are to be applied in that area. Here we are going to project the data into lower dimensional space by maximizing the variance. And we can also go with the distributed stochastic neighbor embedding application. Here we are going to project high dimensional data into lower dimension while preserving local structures. And the last one is autoencoders, neural networks. Here we are going to apply for represent the data. And the third one is about association rule mining. These algorithms are find relationship for association between variables in the large data set. The first one is we can go with the a priori algorithm. Here we are going to find frequent item sets and generate association rules based on the minimum support and confidence. And we can also have a FP growth. Frequently it is called as frequent pattern growth. So efficiently minimize the frequent item set without candidate generation. So the next is neural network approach. Unsupervised neural network learn data representation and structure without labeled outputs. So we can have a different kind of approaches are there in unsupervised learning, autoencoders, self-organizing maps and generative adversarial networks. So in autoencoders, we are going to compress the input data into smaller latent space and reconstruct it into back. And in case of self-organizing maps, create a low-dimensional representation of data using learning. Then in case of generative adversarial network, generate a new data sample similar to the input of training data. In the unsupervised learning, matrix factorization is a very important factor. These methods decompose the matrix into smaller components to uncover hidden patterns or relationship in data. So this kind of matrix factorization is to be very useful in a recommender system, used in recommendation system and collaborative filtering. So here we can have two different kind of approaches in unsupervised learning matrix factorization techniques. Singular value decomposition. Here we are going to decompose a matrix into singular vectors and singular values. The next thing is non-negative matrix factorization, NMF. Factorize the matrix into two non-negative matrices. So the next is principal component analysis, PCA. The goal is transform the data into a smaller dimensional space while preserving the variance. How it will works? The first we are going to find out the covariance matrix of the data. The next is find the eigenvectors, that is principal components. Then we are going to project the data on the top of the components. Here we have many use cases are there. With the help of this PCA, we can go with the good feature extraction methods and we can easily project the data. So it's very useful in all kind of recommendation system. Thank you, learners. With that idea, we just closing unsupervised learning in machine learning. Then next we will see about how this unsupervised learning to be very useful and how we can cover all kind of limitation of classical machine learning in quantum computing. Thank you all.